Hi, this is Ty from Total Finishing. Today we have a lab test getting ready to go underway for our customer TAS. Your part is this metallic part. You've got a groove or slot here, and the object here is to paint just this carbon steel part that's not galvanized on all sides. So you sent us, I think, 100 or a couple hundred of these, and the idea that was pitched was it's going to go on your cart. You're going to throw a lot of them on here, pull the cart in on through some sort of a tow cart line in front of the robot and paint them. Well, that could work. In reality here for a lab test, it won't work, and I want to explain why. For one, the cart that was sent in is just absolutely covered in overspray, like it's probably a 1/4 inch thick, and this is going to be sprayed electrostatically, so we need the parts to be able to be grounded. So the cart would have to be, bare steel and grounded. Right now, it's too insulated for that to work. Secondly, we need to be able to have the parts repeatedly placed on every cart exactly the same. So it honestly would be easier to start this idea by having you fabricate a whole new cart. So right now, if I set this on here, there's nothing that guarantees I'm going to put it too far in, too far out, one too close to the next one. There's nothing that regulates that. There's too much room for human error, and that's going to cause a miss with the robot or a collision or something else. But we came up with a pretty easy solution, and we're going to implement it for our lab test on the robot that we have. We actually took 2 of your pieces. You can see here they have the groove in the center, which happens to allow the center space here to easily slide right here. So what we did on our robot is we actually cut some of these in half. We put a little band on so that the robot the piece can't shift in the slot. And of course, in this instance, gravity takes it to a known stop point. So we're able to put this on, slide to a known stop point, and then if you actually continued with our idea and fabricated a rack, you would have basically known slots where to put the part. You push them all the way back to a stop, and then you have a repeated pattern that can be done. But like I said, with the way this showed up, it's just not possible with the tools, fabrication equipment we have here to do that. I'm sure for you as our customer who has all this metal cutting, fabricating tooling, you could do that. But here at a lab, we don't. So now I'll take you into the robot and I'll show you how we've implemented that change here. Okay, so we're inside the robot cell. We have the safety fencing that would be around the robot. And in this case, we have what we call our carousel robot, which is a little different than what was quoted to you, but it works great in our lab. It actually simulates a conveyor system. So these 3 arms spin around the base of the robot, and then these 3 pedestals on the end of each arm, we're able to spin them 360 degrees. So we fabricated these holding brackets out of your actual parts. Our robot is grounded, so these arms are grounded, the parts are grounded. So like I said, we simply take your groove side out or in, slide it in. We have this little band welded on so that it can't tip over and fall out, but it's going to a known depth every single time. So when I put these parts in, it's going to be in a repeatable place every single time. So the operation of this will simply be an operator standing on the other side of this fence. This is a cutout for safety. He'll slide 3 pieces on, and away it'll go. 3 pieces that were painted will come in. He'll take those pieces off, and in this exercise, we'll be putting it on your rack, and then we'll repeat. I think your requirement was to do 3.6 pieces per minute. We're going to be able to hold 9 on here. We'll do an actual time trial. But I'm thinking we can get about 7 pieces a minute just on this setup, potentially 9. So we'll see how fast we can go with that. So now we'll move to the robot itself. All right, we've loaded the work pieces like I showed you earlier into their slots. There's a band across the back welded on so that they can't tip backwards. And we're at a known depth every time. and we have part rotation control and all of that. So a couple of safety things. When you're in here doing the spraying and we're going to turn the electrostatics on, you want to be wearing eye protection because the best ground on your human body is your eyes. And so if you get closer to the workpiece, which is grounded, than the paint, which is electrified, it'll go to your eyes. So always when you're working with electrostatics, wear safety glasses. You should also wear leather-soled shoes or a grounding strap. I actually don't have that today, but it'll be quick. Another thing, you always want to flush and fill with a metal bucket that's grounded. Okay, so we actually have a ground wire over here because plastic can build up a charge, and when you go and touch it, you could set it off if you've just been dispensing solvent or flushing or something like that. So always use a metal container when flushing or loading on this system when you've got electrostatics. All right, so we've got the robot in teach mode. Our controls are lock and unlock the robot, start and stop record, trigger, like as into spray, and part rotation. You unlock it. Electrostatics are off, right? Yes, sir. Okay. All right, so I'm going to unlock it. We're going to do a hard brake. I'm going to unlock it, press record. All right, I think that looks like a good recipe. We'll save that. We'll give it a file name, and then we'll go into production and see what it looks like. I think that looks pretty good. So we'll save that as a recipe, and we'll play that back in real time. Okay, so we've saved the recipe. We're going to go into production mode. We're going to turn on the electrostatics. Steve-O is going to unload wet parts and load new unpainted parts, and we'll be able to do a time study and tell you how fast basically we can paint 3 parts or 9 parts here on one set. All right, so let's go, guys. I want to point out at this point, before first rotation, Steve-O, without really having to hurry, already changed out the 3 parts that were painted to 3 new fresh parts. So we can track that in the video timing. Playback speed on the path from the robot is also increased to 140% of the speed at which I painted. So it is also spraying faster than I did. That would be end of first cycle, so we'll check the timestamp here. Again, Steve-O's got plenty of time. So he's able to actually have a little rest in between changing the parts, which is good. I think the operator wouldn't get fatigued in that instance. That is a thought, but you're adding labor. You could have a separate unload and load station if you really wanted to make it easy on the person, but I think the point here is to reduce head count. Go ahead and hand me that one. I want to inspect paint quality. So on this one, just want to look around at the part itself. We've got full coverage. Good wrap, smooth finish. I would think that's a pretty acceptable part. Make sure those aren't touching. One thing the carousel robot also does for us is it's grounded. So we've already tested the ground to make sure all the parts are grounded, but that keeps everything fresh and new, always grounded, so you're going to get the proper amount of wrap with this setup, unlike the parts which would probably build up with paint. You didn't add more, right? You didn't add any more because I had a set amount I wanted sprayed. So at this point, because these are the last three that we're going to spray, Kenny's just going to hit the stop button. It will still finish the cycle if it's not an emergency stop. I believe we painted 27 total in the period of time of this video, plus the original three that we trained on. So there should be a total of 30 painted. Perfect. That concludes our painting demonstration here at the lab today. I hope that was educational. You're able to see a lot of time studies off of this. Contact us at totalfinishing.com if you have further questions. We'd love to help you with your project.